Hello, Mr. Luong. This is my FAQ number 6. So I'm going to look at this problem and the plane as like this. So this is going to be the x. So this is going to be the y and that's going to be the x. And I want to draw this so that it's easier to explain things later. And then, I want to draw so I can find the acceleration in the y. So acceleration that's acting against that down, the acceleration in the y from the ball. And acceleration in the y is going to be affected by this angle right here. I'm going to call this data 1 and this data 2 because I don't know what that symbol is called. But yes, that is called data 2, okay? Called data. Okay, you already said that. I don't need to write it, right? Okay, yes. So to find the acceleration in the y, it's going to be affected by the FGX. And I know net force of is going to be MAY. So let me write that. And then whatever that weird symbol is. And then it's going to be MAY equals to mg sine of that. And I know this is going to be that because there's no friction. So it's just going to be the FGX affecting the acceleration. So m cancels out. So then the acceleration in the y is g sine of symbol of data 2. And then to get the delta max formula, or not the delta max, the maximum distance up the board, that's going to be the H max formula, or the H max, finding for H max. And before I know that the H max happens at the peak, and then to find that I need to know the time for the peak. And I know I can use this formula VFY equals to AT plus VIY. And then I know at the peak there's no VF, there's no VY because it's just the VX sitting there. And then it's going to be subtract VI to the other side. And VIY, yes, that's very important. VIY is going to be VI sine of theta over negative G sine of theta 2 because it's acting downwards, so the negatives cancel, and you get T equals that. Yes, that is T peak. And then I know I can use this formula, the displacement formula, VIY T plus 1/2 AT squared, to find the H max because I know I can set VIY T equal to 0 because I'm going to look at it like this way, going that way, because it's going to displace the same distance, but yeah, over there it's going to be negative. But I'm going to look at it over here, or you can also look at it backward. Either way, just as long as you start at this peak, it's easier to find the H max because VIY is 0. So then that's why I can DIY, not DIY, delta y, delta y 1/2, and then plug in AY. I keep forgetting the AY. I keep forgetting that Y. That's so annoying. Okay, AY is going to be G sine of that theta 2. And then this is going to be T peak because, like I said before, it takes T peak time, seconds, T peak seconds to reach the maximum height. Wait, it takes this amount of time to reach the maximum height. Why do you, okay, oh my god. Okay, let's stay on track. 1/2 G sine of theta 2, and then T peak, so I plug in VI sine of theta over G sine of theta 2 square. So then delta Y is going to be 1/2 G sine of VI square sine square of theta all over G sine of that. So then that cancels out. Oh, no. I just forgot the square. Not excellent. So then that G cancel out, that sine cancel out, and you're just left with 2g sine of theta 2. So then to make this prettier, delta y, or the h max, let me rewrite that. H max, so which is the maximum distance the board will go up before it slips down again, is going to be vi squared sine squared theta over 2g sine of theta 2, which makes sense with the other h max formula when there's just gravity, but this time it's just with this kind of gravity because it's on a ramp. Yes. Okay, for part B. Part B, I know the distance is going to be the VIX times T total. VIX can be expanded to VI cosine of theta times T total. So then its total time it will take for the ball to reach the target is going to be D over VI cosine theta. Was that part B? Okay. For part C, is it okay if I copy and paste my work here? Actually, I don't think you would like that. Or maybe would you, to save time, so you don't want to listen again. Oh my god, I'm making you listen, so I'm making you oh my, okay, let me start. VFY equals AYT plus VIY. Yes, and like I said before, the time it takes for the ball to reach maximum height is the time it takes for it to reach the time at the peak. So at the time of the peak, there's no VY, so you can subtract, get rid of that and subtract VIY to the other side, VI sine of theta, and then AYT is the G sine of theta 2, but it's negative because it's acting against. So it's pulling down, so negative G sine of theta 2 equals T peak. So then the negatives cancel out, and then you get T peak equals to VI sine of theta over G sine of theta 2. So yes, that's the same as I got before. Now for part D, so for my answer to part C is T peak. What is the necessary time to hit the target in terms of delta Tm? So if T peak equals to delta Tm, and I know that for projectile motion, when the delta y equals to 0, this T peak is gonna take another same time to reach the bottom, because you're traveling the same delta y up here and then you're traveling the same delta y back there. So it takes the same time to travel up and down. So that's why it's gonna be 2 delta Tm as the answer. So the total time, T total, is going to be 2 times delta Tm. Okay, now for part E, I am going to use the range formula and also the what is it called? Okay, I'm just gonna do it. D equals VIX times T total. So yes, we know that. And we know T total is gonna be 2 times T peak, like I said before. And then to substitute in for T peak is gonna be 2 VI sine of theta over G sine of theta 2. Okay, so now I'm gonna plug this T total into here. So D is gonna be VI cosine of theta times 2 VI sine of theta over G sine of theta 2, which is going to be equal to VI squared sine 2 theta, because 2 sine of theta times cosine of theta is one of the thingies or whatever trick, I forgot, but it's going to sine of data, cosine of data is going to equal to sine 2 of data. And then over g sine of data 2. And then I know that I can just do cross multiply. I can just multiply g sine of data 2 to the other side. Or divided both sides by vi squared to get sine 2 of theta. And then I inverse sine both sides. Over vi squared equals to 2 theta. And since all of that equals to 2 theta, and to solve for theta, you gotta divide both sides by 2. So then theta is going to be 1/2 inverse of sine times dg sine of theta 2 over vi squared. Oh my gosh. Yes. And then for part F, if the angle, the data 2 of the board is increased, how would the answer to part A change? So I am going to look back at, let me write the Hmax formula again, because that was what the part A asked for. Data 2. Is that correct? Okay. And then I'm going to write AY again. Okay. Now, if the data 2 increases, it makes sense that AY would increase as well. And also makes sense conceptually because when you increase the angle, it's going to make the ramp steeper. So you're going to accelerate down faster. So when you plug this increase AY in here, right, it's going to make this decrease because you make the denominator bigger. That means the numerator at the top will get smaller because you're dividing by a bigger number. And that means this Hmax, the maximum distance you can go up the board, will decrease. And then visually it also makes sense because when you raise the board, that's like when you make the ball go like closer to the gravity, because like you're making it go like more vertical, and the more vertical you go, the more you approach negative 9.8. And then the bigger the acceleration, that means there's more gravity pulling the ball down, which means there's gonna be more opposing, gravity is gonna oppose the ball more, so it can't just travel higher. Yes, so this makes sense because increasing the data 2 will increase the acceleration in the y, making it closer to gravity, which means pulling it down more, which means you have less delta y. Okay, that is all. Thank you for listening.